Basic principles for project scheduling. So project scheduling, it also it also works on some set of principles. The first one is compartmentalization. What do you mean by compartmentalization? Compartmentalization means breaking down of one major activity into few smaller manageable activities. This is known as compartmentalization. Compartmentalization means when you have a bigger task, when you have some bigger tasks to be accomplished, and then you must divide it into some manageable, reasonable amount of what you can say the pieces. Then that is nothing but a compartmentalization. Interdependency. So there must be certain modules that you have compartmentalized. Earlier you were having a one big project, then you have, let's say, divided it into four smaller modules, four smaller compartments. Okay. Then the interdependency of each compartmentalized activity or task must be defined. Interdependency means one particular compartment is dependent on the completion of the another compartment, another module. So if at all there is an interdependency between various modules, that needs to be identified in prior. If at all there is some dependency, like a particular module should be executed in sequence, then that sequence should be decided in prior. There are certain activities, say in compartment 2, that cannot be started before the output of particular function in compartment number 1. So this particular restriction needs to be identified before, so that all the kinds of interdependency, you need to resolve all the kind of interdependency. Then the next principle is time allocation. So whatever task that you are going to schedule, whatever the task that you have identified for your team, that proper amount of time allocation should be there. So time allocation is, for example, person days of efforts. How many person are working on this project? So one person is working on one particular day, then one person 1 day effort is there. So in this unit you have to allocate a time. In addition, each task must be assigned a start date and a completion date that are a function of interdependencies, and whether work will be conducted on a full-time or a part-time basis. So each task must be assigned a start date and end date. So there are two scenarios. One scenario is that a particular team has been assigned for a work, and all the members of a team are working on that project full-time. The next scenario would be, you have been assigned several projects, and all the projects you are working simultaneously. Simultaneously in the sense, say you are working on 4 projects. So in a day you are working 2 hours, you are dedicating your 2 hours on one particular project. The next 2 hours on the second project, next 2 hours on third project, and last 2 hours on the fourth project. So accordingly your time allocation would be measured. Since you are working on all four projects daily, it cannot be counted as one person 1 day of effort. Okay, one person 1 day of effort means if you are working full day, if you are working 8 hours, 9 hours on that one particular project, it is you have worked one full day on that particular project. Otherwise, when you work for 4 to 5 days, it is counted as one person 1 day of effort. Okay. The next principle is effort validation. Next principle is effort validation. Now validation means you need to reassure, you need to reconfirm. Okay. every project has a defined number of people on the software team. Okay, every project has a defined number of people on the software team. As time allocation occurs, you must ensure that no more than the allocated number of people has been scheduled at any given amount of time. For example, consider a project that has 3 assigned software engineers. Example, 3 persons per day are available per day of assigned effort. On a given day, 7 concurrent tasks must be accomplished. Each task requires 0.50 persons per day of effort. More effort has been allocated than there are people to do the work. Okay, if there are three software engineers that you have assigned, and on a given day 7 concurrent tasks must be accomplished. Okay, and 0.50% days of effort each task requires. So these 3 people can comfortably finish only 6 tasks, but the allocated is 7 tasks. So this should not happen. So more effort has been allocated than there are people to do the work. Therefore, this kind of allocation should not be there. This is known as effort validation. Next principle is defined responsibilities. Every task that is scheduled should be assigned to a specific team member. So defined outcomes. Since you have defined responsibilities, defined outcomes. Every task that is scheduled should have a defined outcome. है ना, ऐसा तो कुछ नहीं होगा कि आपने किसी को बोला है कि आप ये काम करो, बट यू डोंट एक्सपेक्ट समथिंग आउट ऑफ दैट एक्टिविटी. Each and every task is scheduled should have a defined outcome. For software projects, the outcome is normally a work product, the design of a component. अगर किसी को डिजाइन बनाने बोला है तो उससे आप आउटपुट में क्या एक्सपेक्ट करेंगे कि डिजाइन डॉक्यूमेंट बना के दे. अगर किसी से आपने कहा है कि यू हैव टू राइट दिस पर्टिकुलर फंक्शन, सो आउटपुट क्या है, एक वर्किंग फंक्शन आप उसको बना कर देंगे. वर्क प्रोडक्ट्स आर ऑफन कंबाइंड इन डिलीवरेबल्स. So whatever are the smaller tasks, each task will be assigned to a member of a team member. A team member is assigned a particular task. We expect a smaller output from every team member, and all these smaller outputs are combined together in a deliverable module, and eventually it forms a bigger software. Defined milestones. Every task or a group of tasks should be associated with a project milestone. So project milestone, there are several project milestones can be defined. Some breakpoints can be identified, some milestones can be identified. Okay, I mean, if a milestone is accomplished when one or more work products have been reviewed for quality and has been approved. तो हम ये बोल सकते हैं कि milestone का meaning ये कि if we have say several tasks in a project, and if we have accomplished 1 or 2 tasks and the testing has been done and it has been approved for delivery, then we can say that yes, the first milestone is achieved. Now we are working on second milestone. Second milestone, let maybe the coding part. So coding हो गया, testing हो गया, it is finally approved for the delivery. Then second milestone is achieved. So milestone is basically what you can say, a group of it's an indicator that a certain extent of work has been completed and it is ready for the delivery, it has been approved, and as soon as we move closer and closer to the last milestone, we are actually moving towards the completion of our project. Now each of these principles is applied as the project metrics for the software quality. Now we know what is the meaning of metric. Metric for the measurement of software quality. Now the quality of a system, application or product is only as good as the requirement that describe the problem, the design that model the solution, the code that leads to the executable program, and test that exercise the software to uncover error. So what is the quality of a system? The quality of a system, it states that the application or a product that you have developed is good as the requirement that describe the problem, whether the requirement that you have formulated is completely describing your problem or not. The design that you have modeled is giving us a way towards the development or towards the solution. The code that leads to an executable program, the code that you have written, basically it is getting executed or not, it is giving you the desired output or not. And the test that exercise the software to uncover error, whether your testing mechanism is really working towards uncovering all the hidden errors in your program. So 4 tasks are there. First, requirement identification from the problem, requirement identification, then basic design building, then third is the coding, and fourth is the testing. The good software engineer uses measurement to assess the quality of the analysis, design, source and test cases that have been created as the software is engineered. So basically, if you want to assess the quality of an entire software, then you need to focus on these 4 parameters. The quality of a requirement, the quality of model design, the quality of a code, and the quality of your testing phase. So if these 4 parameters should be considered for assessing the quality of a software. The project manager must also evaluate quality as the project progress. Private metrics collected by individual software engineers are assimilated to provide project level results. Although many quality measures can be collected, the primary thrust at project level is to ensure errors and defects. Simple errors and defects. How many errors and defects are that you uncover early in the project development stage? Metrics derived from these measures provide an indication of the effectiveness of individual and group software quality assurance and control activities. So errors and defects, these are the 2 metrics. On basis of these 2 parameters, and performance of individual and performance of a group can be evaluated. Now metrics such as work product, example requirement or design, errors per function point. Now we know what is the function point. Errors per function point, errors uncovered per review hour, how many errors you have uncovered during one review hour. Errors uncovered per testing hour, how many errors you have uncovered during your testing, per testing hour. Provide insight into the efficacy of each of the activities implied by the metric. Error data can also be used to compute defect removal efficiency for each process framework activity. Now these are various what you can say metrics that can be considered, and using these the overall software quality can be. Overview of the factors that affect the quality. There are several factors that can affect the software quality. There a few of them are mentioned here. So these 2 scientists have defined a set of quality factors that were a first step towards the development of metric for the software quality. So these factors assess software from 3 distinct point of view. First is product operation, using it, product revision, changing it, and product transition, modifying it to work in a different environment or porting it. So these 2 scientists have defined a set of quality factors that were used to as a metric for software quality. Now those factors are based on 3 things: how to use your product का operation कैसा है, if you want to change something in the product का revision कैसा है, modifying work, changing it, and product transition means porting it from the development environment to the customer environment. Development environment to the customer environment. So these are the 3 major parameters based on which several factors have been computed. So the framework provides a mechanism for the project manager to identify what qualities are important. These qualities are attributes of the software in addition to its functional correctness and performance, which have a life cycle implications. Such factors as maintainability and portability have been shown in recent years to have significant life cycle cost impact. So it says that the maintainability and portability are the two important factors, okay, in addition to the correctness and performance. So manager should not always focus on the correctness of a code and how fast it is performing, how better it is performing. It should always consider maintainability and portability also in consideration while developing a software. See, there are set of engineers, they can work on it, they can design the product, they can code it, and they can make that particular code run. But since coding and good quality software is not a one time activity, okay, ये एक बार चलने वाला काम नहीं है, इसमें आपको लॉन्गर ड्यूरेशन के लिए मेंटेन भी करना पड़ेगा. पोर्टेबिलिटी मीन्स सपोज आपने एक होता है ना, जैसे फॉर एग्जांपल लेट्स से आप एक बहुत बड़ा शिप बना रहे हैं, तो शिप जब आप बनाएंगे तो आप समंदर के बीच में बैठ के शिप नहीं बना सकते, राइट. आपको वो कई हजार किलो का, कई हजार टन का शिप आप कहीं जमीन पर बनाएंगे, तो आपने ये सोचा ही नहीं कि बनने के बाद उतने भारी शिप को आप उठा के समंदर के बीच में रखेंगे कैसे. पोर्टेबिलिटी इशू. आपने बैठ के बना तो दिया, बहुत बड़ा शिप बन गया, हजारों फीट का लंबा और इतना भारी कि उसको आप उठा नहीं सकते, क्रेन से उठा नहीं सकते, शिप जमीन में चल नहीं सकता. सो बना लिया, बहुत अच्छा बनाया, करेक्ट बनाया, उसका परफॉर्मेंस भी टेस्ट कर लिया, सिमुलेशन लगा दिया, एल्गोरिदम लगा दिया, बहुत अच्छा है, बट आप उसको पानी में उतार ही नहीं पा रहे. पोर्टेबिलिटी इज नॉट देयर. तो आपको शिप बनाना शुरू करने के पहले ये देखना पड़ेगा कि मैं बना तो यहां रहा हूं जमीन पे, बनने के बाद इसका साइज इतना हो जाएगा, तो इसको बनने के बाद मैं समंदर में इसको उतारना कैसे है, सो दैट इसका बनाने का जो पर्पस है वो पर्पस सॉल्व होना चाहिए. अदरवाइज करेक्टनेस एंड परफॉर्मेंस विल बी ऑफ नो यूज इफ यू कैनॉट पोर्ट इट. तो पोर्टेबिलिटी, पोर्ट मीन्स एक्चुअली सपोज कस्टमर एनवायरनमेंट में पोर्ट करना, कस्टमर एनवायरनमेंट में इंस्टॉल करना. सो इट नीड्स टू बी आइडेंटिफाइड, इट नीड्स टू बी टैकल्ड बिफोर यू सी द करेक्टनेस एंड परफॉर्मेंस. Secondly, the framework provides a means for qualitatively assessing how well the development is progressing relative to the quality goals have established. Now the framework means based upon these three factors, how you use it, change it and modify it. Basically the relationship between these three factors is called as framework. So this relationship between how you use it, change it, port it, the framework, it tells you, provides a mean of quantitatively assessing how well the development is progressing relative to the quality goals have established. So helps you to identify. Third point is the framework provides for more interaction of QA personnel. QA means quality analyst personals throughout the development efforts. So framework provides more interaction of QA personnel throughout the development effort. So development and QA, quality analyst, are two different kind of activities. So two types of activities can be there. Once you start development, finish the development, and then you involve the quality analyst kind of a person who will inspect your development work and will provide you some suggestion or solutions. Again, it is a late idea. I mean, after finishing, if they give you some massive changes, again this amount of time that you have spent here, you need to rework. So what this framework says, more interaction of QA throughout the development effort. You get inputs here, you get inputs here, you get inputs here during the development phase, so that whatever is the end product of the development should meet the required quality objective. And last, quality assurance personnel can use indications of poor quality to help identify standards to be enforced